Yeah, that's fine. It's working. Okay,
Okay.
carry on.
Okay, fine. So, Ramesh, I was talking about that firewall. When we are going to implement firewall in the early stage of discussion, when we started to discuss like networking in the beginning phase or N plus kind of curriculum, we used to categorize firewalls like it's a hardware firewall, software firewall. That is good for that moment. But once we are going to manage firewall, or if we are supposed to be a firewall administrators, then we are not going to categorize firewall like hardware or software, because firewall, whenever we are talking as a working firewall, it will be always combination of both. It will be using some hardware, and there will be some certain firmware which will give us platform to interact with that device. So here we are going to categorize firewall based on their working, how they take decision. Based on the decision making criteria, we are going to categorize firewall. So majorly we are going to categorize firewalls into three category, and we used to call it packet filter firewall. And then the second category we used to call it stateful firewall. And then the third category we are going to call it as application level firewall. Nowadays we got another concept as well, that is next generation firewall. We will discuss quickly what that next generation is. So whenever I'm talking about packet filter firewall is the oldest kind of firewall. The first firewall which we developed, that was of the packet filter kind of firewall. Generally the packet filter firewalls are which are going to take decision on the 5 information from the packet header. These are like, if I am going to decide whether I have to allow this packet or deny this packet, to take that decision I need source address. I will check for source port. I will go for destination address, destination port, and then the protocol. So if I'm going to check for this 5 information, that from where packet is coming, what's the source of packet, and where it wants to go, what's the destination of packet, and what type of protocol or which protocol it is going to use, that is good enough to take decision whether I have to allow this packet or deny this packet. And that was the basic nature of packet filter firewall. But when we are going to implement packet filter firewall, it works kind of unidirection instruction. So if I'm saying, let's say one example, that if there is a firewall implemented over here, and assuming it's a packet filter firewall, I have a server hosted on internet, assume it's a public server, assuming address public, and here I have a host in my LAN. For this particular host, I want to allow so that he can browse website from this server using HTTP. So generally what we are going to do is, I'm going to say rule something like this, that if my whatever traffic I'm getting, if it is coming from host and the source port, let me ask a quick question over here, that generally we used to discuss that every services are going to work on some specific port. For example, HTTP works on port 80, correct?
Yes.
Okay, so whenever I'm saying that HTTP works on port 80, is it source port or destination port?
Destination port.
Destination port. What about source port?
So whatever the computer is generating, I believe after whatever the
So
computer is generating.
generally it's a dynamic port or random port. We used to call that should be beyond 1024, correct?
Yes, yes, please.
Okay, so whenever we are talking about that this particular service runs on this particular port, that means it is just for the listening and responding, it not for requesting. If I'm listening for HTTP request or if I'm responding to HTTP request, then I have to use port 80. But if I'm requesting for HTTP, if I'm the client to generate that request, then I have to go with the random port. So definitely as of now, I can't predict any port. So here generally we used to consider it as any, that if traffic is coming from host from any port, but if it is going for destination which is public, and if it is going on destination port, that's assuming HTTP port 80, and then I'm going to say that protocol is TCP, and then I will have one action defined that allow it. Fine. Based on this rule, whenever this host computer will try to access HTTP from the server, this packet will be scanned and passed through the firewall because of this rule. But when this server wants to reply, then when reply reach to the firewall, again it needs a rule to allow that packet. Generally, the packet filter firewalls has default action deny everything if it is not explicitly said in the firewall rule. So when I'm talking about this reply packet will have source address public, and the rule says that packet which is coming from host, that is only allowed. So based on this, this packet filter firewall is going to drop this packet. So to accept this packet, we are going to add another rule that if source is public, if source port is 80, if it is destination to host, and if it is going for any port, because I don't know next time what port it will use, and reply should come on that specific port only. So we need to write this particular rule to accept reply. Is it okay?
Yeah, and the packet filter is okay.
Okay. So once we write this rule, this is how packet filter firewall was working. It's fine, good enough. But once we develop our architecture to work with this firewall, we were able to find one security concern in this architecture. What the security concern is, if you will look at the second rule carefully, this is where we have one concern. What I am saying, that if there is a traffic which is coming from public computer using port 80, it can reach to host on any port. That is which is not acceptable as per the security, that we are going to listen single response of HTTP, and for that I have opened all my port. And then we realize that no, packet filter firewall is not good enough for our need, and this is where we started to feel that we need some updated kind of security product to address this problem. So in packet filter firewall, we couldn't find any solution for it. Max to max, if I'm very keen administrator, what I can do, I can mention over here that port should be more than 1024. But still, I will be able to protect only 1023 port. The rest of the ports are still vulnerable, traffic can come. And if there is an attacker, what he has to do, he has to just spoof IP of public, and he can start injecting packet from port 80. And this firewall will let them go inside. Correct?
Do we have any kind of packet filtering? Because we usually do this on the router, isn't it?
Previously, when we are talking about like early stage of firewalls, the firewalls were supposed to be packet filter only. And as you said that currently also, like mostly in the Cisco ACLs, I'm not talking about CBAC. So general ACLs are supposed to be like this packet filter. If you will think in the current environment, it's very rare to find any product which is still working as a packet filter. So it's kind of history now.
Okay.
Okay. Can you hear me?
Yes. Okay. Thank you.
Okay. Okay. Fine.
We are studying the stateful firewall, which is Check Point, isn't it?
Yes. So nowadays, almost anything which is available in industry from the firewall point of view, whether it is Check Point, Fortinet, Palo Alto, even Cisco, so they are going beyond a stateful. So now a stateful is kind of a basic need. No one is going to implement this packet filter firewall. Okay. So now let's discuss that what this stateful firewall is and how this stateful firewall is going to address this problem. For that purpose, let me just quickly save this slide. I will come back to it, and I'm going to open a new. Okay, so before going for a stateful firewall and to understand how this stateful firewall works, I'm going to discuss one concept just to understand how it is possible for checkpoint to predict that what should be the next packet. So for that purpose, I'm going to take one example. All of you might have heard one terminology. We used to call it session hijacking. Are you familiar with session hijacking? What session hijacking is?
No.
Okay, just for into session hijacking is like session will be initiated by me, authenticated by me, then it will be taken over by someone else. Let's say if I'm going to access my Gmail, so I type Gmail in my browser. Once it will ask for my username and password, I typed my username and password credential. It's get authenticated. But once I got my inbox, one session is established between me and Gmail. And now Gmail is going to identify me that, okay, this is authenticated user. So for each and every packet, it doesn't ask for username and password. So that means they are going to consider me as authenticated user. And for that in the backend, they are going to use some maybe browser cookies, session IDs. So as attacker, if I will take that information with me and I will start pretending that I am that authenticated user, I will get your inbox directly without asking for any username and password. So here what I'm trying to explain that whenever any server is going to communicate with the client, it's a general network behavior that they are going to maintain a session and they are going to identify session with some certain parameter. So let's take one example of TCP IP thing. If there is a client, and here if I'm going to assume a server, whenever I want to communicate with that server, if it is TCP communication, definitely we are going to initiate with three-way handshake, SYN, CNAC, and ACK. But along with that, we used to negotiate one more thing in the backend. That is what we used to call it sequence number. So on the very first packet, I'm going to negotiate initial sequence number. Here I'm trying to explain sequence and acknowledgement. And my objective to explain this sequence and acknowledgement, because the similar kind of approach is being used by a stateful firewall to predict whether this next packet belongs to the existing session or if it is a new session. If you find that if it is existing session, it will take different action, but if it is new session, it requires some different parameter or instruction to handle that packet. So let's say if these two computer wants to communicate with each other, we have a sequence and acknowledgement concept. And that sequence and acknowledgement number both together, we used to call it as a session ID on network level. So this sequence number should be random. Whenever you are going to establish a session or initiating communication with server, it is going to be generated by the system randomly, and it is being used in that session uniquely. Next time if I'm going to re-establish a new session, it will discard the previous session and it will generate a new number. So the process is, let's say if I'm going to use initial sequence number, let's say I got 5000. So along with my SYN packet, I will be sending my initial sequence number that, okay, I'm going to start communication and my sequence number is 5000. And then this thing is now optional. Previously it was mandatory. I have to send an expected sequence number. That means, let's say I'm going to offer him 7000. That means what I want, that whenever you will receive my packet, I want you to reply to my request, and on that reply packet you have to use sequence number as 7000. But as I said, this thing is optional. The first time whenever you are offering expected sequence number, it is up to server whether he will respect your expected sequence number or he may discard it. The reason behind that, as a server, there is no assurance that I'm communicating to you only. I might be communicating to the thousands of clients, and it quite obvious that this pattern or this number is being used in another session. So that is why I'm not bounded to respect this expected sequence number. I can discard it, but that freedom I have on very first packet only. Once I'm going to get this request, then I'm going to respond this packet. On the response, what I will do, let's say this request packet was having payload of 20 bytes. We all have discussed in TCP IP communication that TCP is connection oriented and reliable protocol, correct?
Yes.
So connection oriented means, first of all, I'm going to establish three-way handshake and then I'm going to send packet. That means I'm sure that connection is already established enough. And reliable means TCP is treated as reliable protocol because if you will go in the detail, it is a statement that it will acknowledge for each and every byte. Have you seen that TCP is going to send acknowledgement after every byte? So how this each and every byte is being acknowledged? That answer you will also get in this discussion. So let's say if this request packet was having payload of 20 byte, once it will received by the server, now there are two conditions as I explained, that whether the server want to accept this expected sequence number or discard it. So if he want to accept the sequence number, he will configure sequence number 7000, what he was expecting. But let's say if I by any reason I can't use it, so I can change it. So if I'm changing it, I will send my ISN, initial sequence number. And then if I have received all 20 bytes, I am going to send acknowledgement for 5021. So acknowledgement is not about what I have received. Acknowledgement is about now what I am expecting from you. By implementing acknowledgement concept in this way, with the single packet, we assure two things, that okay, up to 20 I have received and all bytes were readable to me. I'm okay with this. You can send the next block. So that is why I'm going to acknowledge 5021. Let's say out of 20, I got only 10 bytes. So I will acknowledge for 11. So he will automatically assume that, okay, some of the bytes got disturbed or he was not able to get it. Now, once he will get this packet, assuming this was having payload again 20 byte. So next time, whenever this computer will reply to this, he has to use sequence number. Initial sequence number is only on the first packet. Then they have to switch to sequence and acknowledgement. So I have to use sequence number 5021. And same way, if I have received all his packet, I will acknowledge for 9021. So here, if you will check that this pattern is going to work as a session ID on the network layer for them. So if I'm sending response from here using same IP, same port number, everything is same. But let's say if the sequence number is 8000 and acknowledgement number is anything which is not relevant to this pattern, let's keep it 5010 or something. So this is where this computer or this TCP/IP stack will able to predict that, okay, this packet is not part of this particular session. This session should move in this particular pattern. So he knows somehow, if I have sent this packet and my payload was 40 byte, so immediately this computer is expecting that whatever packet I will get as a reply, it must have sequence number 9021 and acknowledgement could be somewhere between. If I'm sending 50,021, so either he has lost everything, so you will acknowledge again for 50,021, or if I have sent 40 bytes and if he has received all 40 bytes, then he can acknowledge for 61. So your window is between this. If I'm going to use something else, he will able to predict that no, this packet doesn't belongs to this particular session, although it is coming from same IP, same port number, and he will be able to discard it. This is what we used to say session ID, and that is the relation between sequence number, acknowledgement number. Okay, any question on this? Now let's see how this stateful firewall is going to address our previous problem which we faced with packet filter firewall. Now, as we discussed with this packet filter firewall, that it is going to use source address, destination address, and source port, destination port, and protocol only. If it is a stateful firewall, it is going to check few more things. For example, like it can go for sequence number, acknowledgement number, similar kind of pattern analysis. And now in the stateful firewall, we are going to implement an architecture. For the reference, a stateful concept was developed by Check Point, and they are the one who introduced this stateful kind of concept, and they have patent to it. Later on in industry, everyone started to use it. So in a stateful approach, what they came with firewall, that okay, now firewall is not going to check only rule base. Now they made 3-stage decision, and this 3-stage decision is, first of all, each and every firewall is supposed to check its state table, and the first decision has to come from a state table itself. If I'm unable to take any decision based on a state table, then I will go for rule base, and if I find a matching rule, it will be taken as per the rule. But if I didn't find any rule, then I will go for default action, which is deny. While in the packet filter firewall, it was rule based and default action only. Now let's understand how this stateful firewall works. So imagine in the same scenario, if this firewall gets upgraded to the stateful firewall, a stateful firewall is more intelligent than packet filter firewall. And just like in the networking, we have discussed about switches, that switches are smarter than hub. They are going to maintain a CAM table. Similarly, a stateful firewall based on traffic. As an administrator, you don't have to do any manual effort to it. If it is a stateful firewall, whatever traffic it is going to allow or check, for that it will start maintaining a state table. And whenever new packet hits to firewall interface or firewall kernel, it is going to check a state table first, that do I have any matching entry in the state table. If it is there, it will be handled by a state table itself. If not, then it will refer to rule base, and then it will go for the default action. So assume same scenario. Let's say this host is going to send a request for HTTP. So this is the first rule because of which this firewall will able to send that packet out. Now a stateful firewall says that I'm smart enough to decide for the reply rule, and that's why you don't have to worry about reply rule. I don't need any reply rule. So he removed this complete reply rule requirement. So if I don't have any reply rule, what it will do, as I explained, that if it is a stateful firewall, it will maintain a state table. So along with this, whenever it will get working, it will be maintaining a state table. And within this state table, let's say this host wanted to send a request packet, and at this moment he has used port 5000 to generate this request. So he will maintain that there was a packet which is from host. It was using port 5000. It went to public, and it is going on port 80 using TCP. And then it will maintain additional parameter as well, like your sequence number was X, acknowledgement was Y. Along with that, what was the state of communication, like it was a SYN packet, if it was a connection initiation, or if it is a time wait. So it will maintain a state of communication also, connection established, time wait. And then it will mark your response that action was allowed. Now when this server will try to reply, just like packet filter scenario. Now when this reply packet will come to the firewall, as I said, if it is a stateful firewall, the first check it will go for a state table, and in the state table it will look for a matching entry. Whenever I am comparing against a state table, we have rule of reverse triplet. These four things get reversed. Get reversed means source becomes destination, destination becomes source. So that means as per this state table entry, this firewall is instructed somehow that if there is a packet which is coming from public, if it is coming from port 80, if it is going to host, and if it is going to a specific port 5000. So you can see that what problem I was facing in the packet filter firewall, that I don't know the port, that's why I was opening all port. But now I'm able to predict that what exact port I have to open. So I'm going to expect this traffic on port 5000 only. And then after, although all these entries are matching, still it is not good enough to accept that packet. I will check that protocol should be TCP and it should have a related sequence number, related acknowledgement number, what we discussed on the previous stage. So it can predict that, okay, if this sequence acknowledgement pattern is matching with this or not, a state of communication is matching or not. Like if it is TCP communication, then very first packet should have always a SYN flag. And if it is reply to the SYN, then there are only two possibility. Either I can reply with SYNAC or I can reply with the reset. If I'm trying to reply something else, let's say urgent, push, fin, so immediately it will discard, although all these criterias are going to match. Based on this state, it will discard that packet. And in the log, you won't be able to see any rule number. The log, it will generate that out of a state packet. So based off out of a state thing, it will discard that packet. But if this complete state information is also in sync, it will able to match the state, then it will accept this packet. It doesn't need any rule in the rule base. That is what the state based decision. But if it didn't find any entry in the state table, then it will go and refer the rule base again, that do I have any rule to accept this packet? If there is a rule, it will be accepted by the rule. If there is no rule, then it will go to the default action and it will discard the packet. That is what a stateful firewall is. Is it okay?
Yes, yeah.
It is okay, but
Yes.
does this kind of scenario happen? Like all these four things matching except this all. Does this kind is happening in the firewall?
Sorry, I'm unable to hear you properly. Can you speak a
Okay,
bit
can you hear
loud?
me now? Can you hear me now?
Yes, it is a bit better.
Okay, I just would like to know, is there any scenario where we can see all the reverse packet
Okay.
is matching all this like host and this host source and public IP address, but in terms of the protocol,
Yes.
it will not match, or is there any scenario? Because most of the time, when the packet is going, it will be allowing from the packet is coming from the same host, isn't it? Or is there any scenario where the packet is dropping? I mean, you
Let me
already met.
repeat. Let me repeat your question, and you have to tell me if I understood correctly. That what you are asking, that is there any specific scenario where we can see that if there is any packet which is being accepted by cause of a state table, or if it is being discarded because of a state table? Is it correct?
Yeah, because of just to slide, because when the traffic is going
Yes.
and connect and the same port 80, when the
Yes.
traffic is coming back, although
Yes.
all this host and the public IP is the same,
Yes.
and does any scenario comes like your TCP is changing? It could happen. It could happen, or any scenario. Can you give the example where because very very limited experience, but we didn't see anything, so that's why we like to know.
Okay, so if I understood correctly, you want to see that if somewhere you can see the message, although it is coming from the correct IP and correct port, but because
Yep.
of this sustained kind of state table additional information kind of thing, because of that it gets filtered out.
Or
Is it
filter, or
correct?
is yes, correct, or is maybe change TCP, like the host is going with talking with same server TCP, and then when the traffic is coming, it could change. It could change, or is there any scenario where you know in the industry or in the firewall?
Okay.
So,
If you want to see that where it could be changed, so there are two stages. Some of the protocols which is going to do this change as a legitimate behavior of the protocol, like FTP. So for that kind of stuff,
okay,
these stateful firewalls are going to have a security gateway for that specific services. Okay, so they have that protocol running on their firewall, and they know the complete architecture and status of the firewall. If I will take example of FTP, so we know that FTP is going to use two ports. So if I'm going to send request on 21, so definitely he will try to open up a data port which is 20, or it can be random also. So for that kind of thing, it is going to run a FTP security gateway, and it will monitor that if it is going for FTP request, what port request is coming from the server. Then he will dynamically open up a request for that specific port. But if you want to see deviation and packet is being dropped, so in checkpoint, whenever you will go for the smart view tracker, we will see during the practicals, in the smart view tracker, whatever logs are being recorded as a out of a state packet, so they are filtered because of these things only. If it is filtered because of the rule, it will say the exact rule number. Otherwise, if it is in description saying that packet dropped and description says out of a state packet, so that means it was dropped because of this additional information was not matched.
okay, okay. You will, okay. Thank you for your comment.
Okay, so you got answer to your question?
Yes, hopefully, yeah. Thank you.
Okay, okay. Any other question from anyone else? See, in the online session, at least you can just respond so that I can make acknowledgement like TCP that at least you are listening to me, or we are connected, or we got disconnected, because I can't see your face.
Yeah,
Okay.
Well, I think,
Very good.
Sushil sir, most of the guys are maybe in the mute. So I think if you're not hearing something for few seconds, then we're assuming that nothing. Or guys, there is a chat window. You can maybe reply that. But I think at least one guy say, fine. Um, that's
Yes,
another thing.
this is just for the like TCP acknowledgement thing, that if anyone can at least say, so that it is just acknowledgement for me that I am connected, because my screen is just this PowerPoint slide, and I can't see my if my LAN is connected or disconnected. So maybe I'm just going with the session and I am
Very
out of
good.
the session.
Very good example given with the colleagues. So I hope other colleagues could understand your things and should reply. Yeah, very good example.
Okay, so now I'm moving to the next type, that is application level firewall. So here, this application level firewall, which is not something totally different like architectural change between, if you compare packet filter and a stateful filter, here we did some architectural difference. But in the application level firewall, in simple, I can say that apart from these things, we started to check for payload as well. So these two firewalls were basically taking decision based on the header only. They were nothing to do with the exact packet payload. Let's say, for example, if I'm going to say that if I have this server and I want to protect it, and let's say if it is a FTP server, and I'm going to put a scenario that I want this FTP to be public FTP, anonymous user can access it. But along with that, I have two requirements, that all public user can download data from this FTP server, but they cannot upload data to this FTP server. So this is somewhere we are looking for an application level firewall, because now my decision should be based on payload, because the header information will only say that if it is a FTP packet. But I don't want to decide whether to allow this packet or deny packet based on the type of protocol or service he is using. Instead of that, I want to see what command actually he is using. So whether he is using put command or get command. So that I have to look into payload. Payload is the actual thing which is being transmitted on the network, user information or user data. Additional information is being coded by your application softwares or TCP/IP stack, which we have discussed already in OSI model. Okay, so application level firewall is once I will start looking into the payload, like what kind of information is traveling, what command you are using, whether I'm using get command, whether I'm using put command, or if I'm sending any malicious kind of traffic like URL filter, antivirus, IPS. These are the example of application level firewall. Got it?
Yeah, got it. Very good example.
Okay, so now if I'm going to talk quickly, as we discussed that we are calling another term also, and which is nowadays most trending one, we are talking about next generation firewall. So next generation firewall is one bit more advanced to this. All these generic firewall is still their basic decision making criteria is on protocol, port number. But now we have developed firewall on which we are not going to be a specific like traditional firewall to check which protocol, which port number. Instead of that, we are directly checking the application signature. Like might be it is possible that I can configure my telnet to work on port 80. So traditional firewall will consider it as a HTTP traffic if it is going on TCP port 80. But next generation firewall has the application signature, which can identify by the few first packet exchange that whether it is HTTP packet or whether it is a telnet packet. And based on that identification, he can take decision. It is not more bounded only with the protocol and port number. So that is what the quickly idea about this next generation firewall. So I guess, Ramesh, is it good enough like the basic thing? Now we can proceed to the checkpoint specific information.
Yeah, it is good enough. We can, yeah, move on.
Okay. But still, like during the discussion somewhere, if you feel like that, okay, because of I'm new to the security, I'm unable to get this concept. So you have to just let me know. So we will see that how much we can help you. We will try our best, but definitely we won't be able to cover each and everything just because of the time limitation.
Sure, that's fine.
Okay, so now quickly I'm jumping to the checkpoint thing. What checkpoint is, whatever we have discussed till now, that was just generic discussion which is applicable to each and every vendor. Doesn't matter which vendor it is, these concepts are applied to each and every one. As I said that this is a stateful kind of thing, this is invented by Checkpoint, and they are the one who discovered it, and that's why they got credit in industry as a pioneer in firewall industry. And Checkpoint is a company which is purely into the security. Like if I'm talking about other vendors, Cisco or Juniper, they have routing also, switching also, and security also. But Checkpoint from beginning, they are into security only. So now I'm going to give a quick history about Checkpoint. So when they started to build firewalls, previously they came up with a software package for the Checkpoint firewall, and that software package was supposed to be installed on any operating system and on or any hardware, and then we can configure it and start using it on in network. Then down the line they realized that if we are developing a Checkpoint a firewall package and we are using operating system which is designed by someone else, like Checkpoint firewall, even current days also, it can be installed on Windows operating system, it can be installed on Linux variations. Okay, so if this Windows is designed by Microsoft and this package is designed by Checkpoint, and the package requirement is because it is a firewall package, it needs to work closely with the operating system kernel to take decision whether this packet should be allowed or not. So when Checkpoint started to add some more functionality to it, because nowadays it's a trend of UTM, and Checkpoint is UTM actually. What is UTM, by the way?
Unified Threat Management.
Unified Threat Management System. So if I'm talking about our network, generally the network is we used to have a router, then this router is connected to a firewall, this firewall is connected to IPS. Okay, this IPS may be then further connected to antivirus, and then it may be connected to any URL filter or proxy kind of stuffs. And this is how multiple level of scanning. So nowadays, instead of doing this, what we have done, we merged all these things together in a single box, and whatever box is going to offer this thing is treated as UTM, Unified Threat Management System. So it can be multi-purpose device. It can act as a router, it can be firewall, it can be IDS, IPS, URL filter, or antivirus, spam, anti-spam. So all these security things are there. So Checkpoint is actually UTM vendor, and it is going to provide UTM only. So when they started to add this feature, let's say I want to introduce URL filtering in my firewall, I want to introduce antivirus in the firewall itself, so they face challenge that because that different vendor which was developing operating system, it doesn't know anything about Checkpoint architecture, and Checkpoint was not well aware about their operating system kernel. So this integration start getting a challenge, and then they decided that it's better if we can develop our own operating system as well. And then at that moment they used open source kernel, which is Linux kernel 6, and they developed one operating system. They called it secure platform. In industry, in short, we used to call it splat. Okay. So the complete name was secure platform. Secure platform, nowadays you don't have to worry about this kind of things. It is just like a history now. Splat you might see somewhere, otherwise everyone shifted to Gaia now. A splat was supposed to be into addition, a splat and a splat pro. The difference between a splat and a splat pro was this: splat pro has dynamic routing support. So it was supporting industry standard dynamic protocols like OSPF, BGP. So they built one operating system, and then they started to integrate their product with this operating system, that okay, splat, if you're going to use our Checkpoint package with the splat operating system, each and every feature will work. Because if I'm going to install this Checkpoint firewall on Windows operating system, URL filter I can't use, antivirus I can't use. So just for the integration purposes, they have developed their own operating system, which was based on the open source, which was using Linux kernel. They started from 2.4 and they went up to 6. So this is what splat is. But once they started to offer a splat and Checkpoint package for Windows and Linux operating system as well, at the same moment there was another vendor in the industry, Nokia, who was developing one IP boxes, that was hardware devices which can be used as a router or which can be used as a firewall. So they used to develop hardware, and they used to develop one operating system for it, that was Unix based operating system derived from Unix. They used to call it IPSO. And most of the people at that moment, they were quite uh, interested to use these IPSO boxes in the network because of the performance. So then they started to release Checkpoint package for IPSO operating system as well. So at this stage, there was another trend that we used to purchase boxes from Nokia, which comes with IPSO operating system. And then on top of it, they used to call it as IP boxes. The series is where IP390 or something started with IP. So on these IP boxes, you need to install Checkpoint package, and then it becomes Checkpoint Firewall. The advantage of using this IPSO box was because this splat operating system was derived from Linux kernel, which was a desktop operating system, and in a splat pro they introduced dynamic routing, but because of the operating system architecture, they were not able to further extend it. This operating system was having issue to support different routing protocols, and even the BGP or OSPF things was supported. But if I'm going to run BGP with public router, it was not able to perform as per the expected. It was too much of lag. and it was unable to handle that routing because this architecture was for the desktop operating system. But whereas this IPSO operating system, it was good for the network operating system, and it has very good support for this dynamic routing, BGP and all this stuff. So that's why people started to use this IP boxes. Down the line, Checkpoint got opportunity to purchase or take over this company. So they purchased this complete Nokia project along with IP boxes and IPSO. Then they realized that they got ownership to IPSO as well, and they got ownership to a Splat also. But both of these operating systems were having some advantages and disadvantages. If I'm talking about a Splat was good for integrity. All features were supported when this package was completely integrated to it, but dynamic routing was challenged in it. If I'm coming to IPSO, its routing was very good, but the package integrity was challenged over here because this IPSO operating system was from somewhere different vendor. Another challenge, this IPSO operating system can be installed on IP boxes only, and Splat was having challenge that it can be installed on i386 architecture only, the desktop, laptops or servers only. Then Checkpoint decided that let's make a universal solution which should have good things only from both of the flavor, and they came up with this operating system what we are going to use today, that is Gaia. So in Gaia they tried to merge this Splat kernel and this IPSO routing features, and now they made it universal operating system. That means now Gaia can be installed on IP boxes as well. It can be installed on i386 architecture as well, and it can support complete dynamic routing. It can be very good for integrity. Okay, so this is how we came up with the Gaia, and Gaia is the recent one. So till now Gaia is the latest operating system which is recommended by Checkpoint. Got it?
Very detailed knowledge. Thank you.
Yes, yeah.
Yes. So once we have done discussion with the operating system side, now we are going to discuss something from their Checkpoint architecture side. So you might have heard that Checkpoint works in 3-tier architecture. We used to call it, it's a 3-tier architecture. 3-tier architecture, why they developed it, what this 3-tier architecture is. So the objective was quite simple. Checkpoint says that the architecture which we are developing as a 3-tier architecture, it will be good for centralized management, and if I want to scale my management to from one firewall to even thousands of firewall or millions of firewall, I don't have to do major change. This architecture is designed in such a way, and that is what we are going to call it as 3-tier architecture. Within this 3-tier architecture, the tiers are, we are going to call them security gateway, the second is security management server, and the third one is a smart console. After this point onward, I won't be referring this component as with this name, security gateway, security management server, and a smart console. From this point onward, we will be calling it SG, SMS, and console. Now, what these three components are? So let's start with security gateway. Security gateway is actually your enforcement device. So this is the component which will be acting as a firewall, and this is the component which is actually going to filter your network traffic. It has to check that what traffic should come inside, what traffic should not come. So I'm going to call it as enforcement node. This is what actually enforcing your network policy. Okay, and this component is actually treated as a firewall. Now, if I'm talking about second component, that is security management server, and in short, we are calling it as SMS. This is what actually a kind of database. And its role to the checkpoint architecture is it is going to act as a centralized database which will be storing all the policies, all network objects, even your logs. Everything is getting recorded on the security management server. But security management server is not going to enforce any security. The filtering has to be done by security gateway. But to do that filtering, how I have to filter, what traffic I have to allow, what traffic I have to deny, that information he will get from management server. Correct?
Yes.
And then this smart console. By the way, just to refer, this is the only component in Checkpoint which comes free. You don't need any license for a smart console. So a smart console is going to act as a client tool. It is just like your graphical client tool which will give you platform to interact with SMS. So whatever rule I want to create, whatever changes I want to make, what object I want to create, whatever policy I want to define, everything has to be defined on SMS. But as an administrator, I can't access SMS directly. I have to access SMS through this console. So console will give me a front end to communicate with SMS. So in general, or in a layman understanding, we can say that a smart console is our front end interface, and SMS is actually your backend where you are going to do all the changes. And then this SMS is going to send all these change or update these changes to the relevant gateway, and then those relevant gateways are going to enforce that security in the network. Correct?
Yes.
So if we are going to represent them graphically, this one will be the graph which I will be using for represent firewall. So actually this is what your external communication, or what it is going to be connected to the firewall. And here you might have your SMS, and then here I can have any Windows PC. On that, console will be installed. So as an administrator, I'm going to access this Windows PC through this console software. I will be connected to SMS. I will create all the rules, object, policy, and I will save it on the SMS. This SMS will be acting as a database, keeping record for all these things. And then once I will click on push policy, it will send only relevant policy to the gateway. Let's say this SMS, it's not necessary that I can have one SMS per gateway. I can use single SMS to manage multiple gateways. One SMS can manage unlimited number of gateways. It's just depending on your license, what type of license you have. So if
I have a
yes,
question here.
yes.
When you creating role, is it on console or is it on SMS?
As I said, console is just acting as an interface client tool. Everything you are creating on SMS.
Okay, thank you.
So just like if I'm going to, let's take one example of browser and your backend server. So if I'm accessing my Google Chrome or something, and within that I got my web page, so whatever I'm doing, it's going to be done and processed on web server,
Yeah.
not on the browser on my local PC.
Correct.
So as for the browsing web servers, you got a web browsers as a console. Similarly, to see the policy, everything, it's being recorded, stored and saved on SMS. But to get them, to edit them, to modify them, we are going through this software that was just acting as a front-end application for us. But
So it's
nothing
just,
is stored on SMS.
sorry, it just gave us an access to SMS.
Yes, it's just an interface to communicate with SMS.
And why we can't directly connect to SMS?
Okay, because this SMS, as we are going to develop this 3-tier architecture, so we don't want it to compromise SMS security. It's a hardened operating system. It will give access only to the console PC. First thing, like you can define access list, that what are the my defined consoles, only he can accept connection from those PCs only. Second thing, this SMS is not designed in a graphical way. It is just kind of a database which is going to act in a database format. It's nothing, no user friendly interface or operating system is available for this SMS.
Okay, thank you.
So just to keep it secure.
So we will be creating the policies and rules on management server and applying on the security gateways.
Definitely true. So we will be creating rules, objects, everything on SMS using console. But console is just like interface. Nothing is going to be stored on console locally. It will just give interface to interact with SMS. Everything is recorded on SMS, but SMS is not going to enforce any security. SMS will be just acting as a memory. It will be just recording it. Then from SMS we are going to push certain policy to the firewall. Then that a specific firewall or security gateway, this is what actually firewall, it will be enforcing security as per the defined policy. Got it?
One question.
Yes.
With regards to monitoring of the checkpoint.
Yes.
So where we is it stored in the SMS or
which thing? Monitoring? That
monitoring,
means
yeah.
you are talking about logs and the
Yes.
that will be recorded on SMS by default, but there is some secondary statement to it that we will discuss while discussing the SMS type. SMS has further subcategories.
Okay.
So as of now, answer to your question is it will be recorded on SMS.
Thank you.
Okay. Any other question?
No,
Okay.
that's fine. Thanks.
Okay, so if I'm talking about 3-tier architecture, these are the 3 components which are important for the checkpoint architecture, and at least these 3 components should be there, and this is what we refer as 3-tier architecture in the checkpoint environment. Now this console can be installed on Windows operating system. As I said, that for SMS and security gateway we have multiple flavors available, like as I said that it can be installed on Windows, we can install it on Splat, we can install it on IPSO cannot hold SMS, but SG can be installed on IPSO. Then we can install it on Gaia, we can install it on Linux. So different operating systems are supported for it. Now there are some important points which we have to discuss over here. As I'm saying that this 3-tier architecture is designed to improve your security. But if you will see, and if I will take one example, let's say as an administrator, if I'm going to define policy using console on SMS, then SMS is going to record it, and then it is going to push to the SG, and then SG is enforcing this security. So don't you think that if there is a attacker or malicious user, and if he might start sniffing network traffic at this point, he will able to get all your firewall configuration?
Yes, because this is I don't know.
The spoofing attack you're talking about.
I'm talking about sniffing only. Yes, the
Definitely,
capturing net.
Yep.
Okay.
It could happen.
So
Yeah.
sorry.
Also, it could happen.
Yes. So definitely as a vendor, when they were defining this 3-tier architecture, they have very good address to this problem. They also predicted that, okay, this could happen. And that is why what they made in their architecture, that all these 3 components, or not only these 3 components, in future, if you will go forward with the checkpoint environment, so many other components are going to be added in advanced courses or lateral courses, but all these checkpoint components are not allowed to communicate in a clear text in any circumstances. Just to address this concern, encryption is mandatory, and they always communicate in encrypted communication. Got it? Now, how this encryption works and how they are going to communicate with encrypted encryption. So for that, we used to call this as a SIC, secure internal communication. Okay, what this SIC says that let's make SMS our center point. So whenever you are installing SMS, next to this we will discuss type of SMS. So in SMS there is type which is primary security management server. So the very first SMS which is going to be installed in your complete checkpoint architecture, so the first SMS has to be a primary SMS only. You don't get option that what type of SMS I can choose. Without any option, the first SMS has to be installed as a primary SMS. And if I'm going to install a SMS as a primary SMS, then on primary SMS it will install one CA service, certificate authority, and which they used to call it as ICA. ICA stands for internal certificate authority. Got it? And then whenever I'm going to add another component to it, so whenever I will be installing console and I will be registering it with SMS, if I'm installing a firewall or security gateway and I'm trying to register with SMS, so on the very first communication, this internal CA, ICA will issue a certificate to them. And using that certificate, they have to authenticate in all followed communication, and they have to do encrypted communication just like SSL, secure socket layer. Now it's a question, do you know how SSL works?
Works on the algorithms.
No, we don't want to go in the algorithm, but because that one will be too complicated for you. We just want to address the simple thing that SSL, how it works, the communication process. Let me just quickly elaborate it, because checkpoint SIC is also acting as a using the same algorithm to encrypt the communication. It will use SSL. So in SSL, what it happens that the special thing about SSL that it's not mandatory to have both of the party to have certificate. Let's say if this is web server and this is client. So this web server, for web server, it's mandatory to have certificate. What is certificate?
It's just for the authentication to that page.
Yes, but if I have to define certificate, what is certificate?
It's kind of license.
It's a container, nothing else. Certificate is a container which holds 12 cryptographic information. Like you got certificate from your universities. You got it?
I think so.
So yes, so I just want to take that example because that everyone must have seen that certificate. Maybe university, college, or any training center, they used to give certificate. So certificate is a container which holds some information. There it is mentioned that who have attended this training or what course. So the name, your course, duration, and how you have performed in it. Something like this kind of informations we are going to put into some certain format, and that is what we used to call it attendance certificate, passing certificate. Is it correct or not? Correct?
Yeah, yeah.
Okay. So similarly on the digital environment, if I want to communicate with you, if I will take one more example with the same scenario with university and college. Let's say if I got certificate from my university that I have done course X from that. So what this certificate is, as I said, that it's a container, but what role it plays for me, if I'm going to say to anyone, or maybe I'm going to an employer and I'm saying that I have this particular skill set, he won't believe me because he doesn't know me. But that university, that organization has a good reputation in the industry, and if I'm saying that okay, I have this skill set and this is certified or this is verified by this particular organization, so based on that organization trust, he will believe that okay, you must have this certain level of skill set. And that is what our college or institution's reputation is. If it is very good college, then definitely he will have better trust, and if it is a bit less trusted college, then I will get less trust of my certificate. Same thing in the digital environment. If I want to communicate with the server, how I can make sure that to whom I am communicating, it is the actual server. Let's say if I'm going to type mybank.com, what's guarantee that whatever page I'm getting, it is coming from my bank only. So for that purpose, we are going to put a certificate, and this certificate we are going to take from CAs, and that CAs have their own reputation like universities and colleges. So these CAs are generally like VeriSign, Thout ASGC you have seen in your browser. And in this certificate, they used to have cryptographic information like what's my host name, what's my IP, who is owner of this particular server, okay, where I'm located. So these kind of details are there, and CA is supposed to get your detail, verify that detail, and once he convinced that actually you are mybank.com and you are hosting this site, then only he will issue certificate to you. And within that certificate, along with this information, there is option to store your public and private key as well. So generally, if I'm talking about SSL, within this, how it will communicate as a client, let's say I don't have any certificate, but this server will have certificate. So whenever I'm requesting for communication, first of all, I will send my request that I want to establish connection with you. Then this web server will send his certificate to me. But in this certificate, he won't send his private key, only public. It could be another discussion what's the public and private key, that will take too much of time. So once I get his public key, for just reference, public key is available to anyone. Anyone can access anyone's public key. Private key is confidential to you only. And if I'm going to use public and private, then if data is encrypted with public, only and only the same user's private key can decrypt it. So after getting his public key in the form of certificate, I will, my browser will generate a random key, let's say ABC123, and this key will get encrypted by public key of the server what I have received, and this will be sent to the server. Once it will received by the server, now the server's private key will be to the server only, so he will decode what key you have sent. So this key will be used for key negotiation, that is temporary key. And then here we are going to negotiate SSL key, if it is 256-bit encryption or whatever key encryption. So that key negotiation is encrypted with this temporary key, and then whenever we will get the session key, that will be used in complete SSL session. So whatever traffic I'm going to exchange forth and back, that will be encrypted with this key, and server will be decrypting with the same key. So this is how SSL works. Similarly, this checkpoint components, whether it is a smart console, SMS, SG, if they are communicating with each other, they will use this SSL encryption algorithm. So there is no plain text communication. If someone will sniff, still you have to be sure that your data is safe. So you don't have any risk with the sniffing. Okay.
So what's the difference between SSL and HTTP 443?
HTTPS, if you're talking about HTTPS, that is what SSL is.
Okay. Okay.
Yes, 443 SSL communication only. This is what, if I'm going to use HTTP, it's work with HTTP only. But if I will switch to HTTPS, that is SSL.
That's not clear text communication, HTTPS.
No, it's not clear text communication. It's the only first request goes in plain text. Then the certificate comes. After that, it is switched to encrypted.
Yeah.
And if you will go with the SSL detail, then definitely there are some certain more criteria that once I will receive the certificate, I'm supposed to check 3 things: who has issued this certificate, to whom it is issued, and how long it's valid. And if I will get any mismatch with these 3 information, your browser will prompt certificate error. Like if it is issued to google.com, in my address bar, the typing should be exactly google.com. If it is showing gmail.com, it will prompt certificate error. And then who has issued this certificate? If it is issued by Thaute, SGC, or VeriSign, that CA has to be in trusted list of your browser. Otherwise, that particular browser will prompt as a certificate error. You might came across with sometimes situation that Firefox says certificate error, but Chrome didn't say, or Internet Explorer didn't say certificate error. So this could be possible situation where that CA is trusted by Firefox, Google Chrome or IE, but not trusted by Firefox.
You mean if we create a rule on a checkpoint and all the
Yes.
rules match, but the certificate does not match, it will drop the packet.
No, this was not about checkpoint. This was about your browser SSL communication.
Oh, it's a browser.
If checkpoint, if you are talking about checkpoint, if HTTPS is blocked, then it won't care if certificate is valid or invalid. It will drop.
No, what I'm saying for
Yeah.
SSL, for suppose sometimes it happened it happened with me. Like some application or some URL works okay with Chrome and Internet Explorer, but when you're talking about the Firefox and Edge, and you can't open the page, it's given for error. So yesterday I was troubleshoot one of the URL and it's giving me same problem. So you mean this problem could relate to the SSL certificate?
Yes, it could be related to the SSL certificate, but here there is nothing to deal with checkpoint. If it is working in one browser, it's not working in another browser, then it's not your firewall fault.
Okay, it's not a firewall, it's application fault.
It's application fault. It might be related to the certificates, but it's not always because of CA. Sometimes it's because of my CA is using different signing algorithm. Let's say if I'm using SA1 or SA2, and if browser is not updated, it's too old or something. So if signature didn't match, then also it will drop that connection. So that it is further diagnosis part. We can't say directly that this can be the only reason. It could have multiple possibility, but definitely, as you are explaining, if it is working with one browser and it's not working in another browser, so this cannot be firewall problem.
Yes. Okay. Yes.
Okay. If it is firewall problem, then it will drop for everyone. Correct?
Yeah.
Okay, so let's get back to that 3-tier architecture. Within that, as I said, that all the components are supposed to do encrypted communication, and in that encrypted communication, they are going to use this SSL for encryption. And these 3 components are a smart console, security gateway, and SMS, security management server. Based on these 3 components, we have our installation, which can be defined in 2 types. So our installation can be a standalone installation or distributed installation.
Sir, can we take a break for 10 minutes or 4 o'clock? We have 20 minutes.
It's up to you. Whenever you feel comfortable, just let
Guys,
me
what
know.
do you think? You want to take a break for now? Sorry, sir. Are you going to start the installation part, or you're doing some theory right now?
I was trying to explain the installation type, and then I was supposed. Okay, so what I was talking about, that if you are discussing about checkpoint environment, so checkpoint can be installed in two modes distributed. So here what we have to take care, as we discussed, three component: smart console, security management server, and gateway. Then you missed the question. In that question, gateway and SMS was on different box. Console was running with gateway.
Yeah, distributed.
Yeah, this is distributed.
Yeah.
So our question was this, that SMS was on different box,
Okay. Sorry,
console was on the gate.
okay, I misunderstood then. Yeah.
Okay, no issues. So what I was saying, that if I'm talking about these three component, make one note that gateway console is not our concern. It could be installed anywhere, whether it is installed on these two boxes or installed on third box, or it is installed along with either one. It doesn't make any difference. Only thing we have to check, if you are answering for the feasibility part, that console must be on supported operating system. Else you have to say that unsupported installation. Otherwise, it couldn't affect to a standalone or distributed. These things should be decided only on these two components, whether security gateway and security management is running on same box, or if security gateway and security management are running on different box. Okay.
Excuse me. Can you give
Yes.
us an overview about the hardware? Which hardware we are using for this? Is it all the time open server, or is it box?
Here in this training, we are going to use open servers, and
No,
even the official.
in real production I'm talking about.
In production, it's up to you. You can use open, you can use checkpoint boxes. It's not any vendor limitation that you can't do this. It's based on the performance requirement. If you have that kind of sufficient hardware available with you, you can go with the open server.
Okay.
Okay. So in checkpoint environment, it doesn't make any difference. And that is why all the official training they have designed on open servers only, on the VMware only. The complete official training, official books, everything is written based on VMware.
So you
And
mean
once
that
you,
the hardware, you mean that it can be the hardware or it can be a software which we can install it on any open server from Checkpoint?
even if it is hardware, what hardware you are saying, that is hardware is designed by Checkpoint, and then on top of that, Checkpoint package is installed.
Yeah,
So what
that's
I
correct.
am saying, that either I can take that company integrated package which is providing hardware and software both, or I can choose hardware from my choice, and then I can run that software on top of my hardware and operating system. So
Okay.
that won't make the difference. If it is running on Gaia, it will support all the features. Only the things what we discussed earlier, that if it is running on Windows, then URL filter, antivirus, this kind of features will be not supported. But if I'm running it on Gaia, whether it is running on open server, or whether it is running on Checkpoint hardware, or whether it is running as a virtual VMs, virtual machines, it
Okay.
won't make any difference. It will make only difference to the performance, nothing else. So if your hardware is able to handle that much of workload, or if your VM is able to handle that much of workload, it's up to you what solution you want to use.
Okay.
Okay.
Thanks.
Yes. So only we need to make our
Can I make
network.
a question?
Yes, please.
What do you mean by the open server?
Open server means I'm just using Checkpoint software package. I may be using my laptops, I may be using any i386 architecture. Let's say I purchased Dell, HP, or IBM desktops or servers, and on top of that I'm going to install Gaia, and then I'm going to install Checkpoint package on it. So we used to call it open servers. That is not given from Checkpoint.
Okay.
Okay, does it answer your question? Sorry, I didn't get your response. Is it okay? I can continue.
Yeah, that's fine. Thank you.
Okay. So as we discussed, that what's the difference between a standalone installation and distributed installation. Now we have next question, that what do you think, which installation we should go for? We should go for a standalone installation, or we should go for distributed installation?
Distributed.
Again, it
Distributed.
Depend on the requirement.
Yes, it could be, but let's say if you want to recommend someone, then what will be your recommendation?
Distributed.
So what's the logic behind that?
If one machine goes, if one machine is gone, so everything is gone.
Yes.
Centralized management. Centralized management.
Centralized management and
And
the
also
backup as well.
your security
Yes.
gateway could not be compromised, isn't it?
Yes. So whatever answer you said, absolutely all these are correct. So all the multiple factors are there. As you said, the first point, single point of failure. So if I'm going for a standalone installation, it's a single point of failure.
Yes.
Second thing is it's not good for scalability. Let's say in future, if I want to implement 20 firewall, 30 firewall, or thousands of firewall, so my management is still bounded one firewall. And let's another thing is, as you said, I think one of you picked that thing, that it cannot be compromised. So generally firewalls are supposed to interact with the external world. So if it is security gateway, definitely it will have connection to the external world, and anything which is exposed to internet, in practical, we cannot say that it's a secure, although we are going to put all the best practices, guidelines and everything. Once it is connected to internet, it's always vulnerable, chances to get compromised, and in that case your complete thing is getting compromised. Another problem, if your box get crashed or any problem you faced, you lost everything. But in the distributed, generally your external boxes are going to compromise or crashed. So if your gateway crashed, you lost only and only uptime, no data is lost. You have to just put another box and push policy from here, everything will be ready again. So in that case, only I have to protect my SMS for the data point of view, and gateway has to be protected from the network uptime point of view.
So most of the environment, I mean, I can
Yes.
see, I mean, the solution is like you have maybe running 6-7 firewall, like we are supporting 7 firewall. So my
Yes.
question is, so why? I mean, most of the time we can see if we are using, we have a server farm, so we have installed the firewall to protect our server for
Okay.
internal and external both.
Okay.
And for the external, we use the internet firewall. So
Okay.
everything can be protected if the traffic is going and coming from the internet. We can. So my question is not possible that one firewall
Uh,
can support both? I mean, can do the internet and the
it
external.
it it can. The firewall product point of view, there is no issue to that, but it's against our security best practices. Best practices.
Okay.
Security best practice says that if you have two different kind of policy and needs and department, let's not merge them together. So just because of isolation of internal to external, we are using dual layer of security.
Okay.
As per if you're going with the product,
Yes. Okay, go on.
it just what scenario you told me, that is just because of the better governance and better policy management. It's not because of the product limitation. Product is capable of handling multiple departments, multiple, as many interface it can support, that much of subnet can be connected.
That's good. Thank you.
Okay, but it's distributed installation. One more advantage is it's somewhere very much suitable and good for a scalability purpose also. Let's say today my network load is not that much of sufficient, so I'm not planning for firewall clustering as of now. But if I have distributed installation, I can plan it any point of time without disturbing my network, without damaging anything. But if it's a standalone, I need to reconstruct my firewall again. Okay, so these are the some advantages of distributed. Workload is divided, security is better, management is better, scalability is there, we have better risk control. That means at least two boxes are dividing and sharing the risk. Okay, my data is safe. If only security gateway goes down, I will lose just uptime, nothing else. If my SMS goes down, I will lose data, but uptime is still there. Yes, these are the different advantages.
My question is, as you
Yes.
explained, as you mentioned before in your class, that one SMS can handle multiple, depend on the licensing. Can
Yes,
handle
it can handle up to unlimited gateways.
unlimited gateway. One thing. So
Okay.
if you have SMS and you have like 500 500
Firewalls.
so you can support it. So what's the
Yes.
difference between this SMS if you have already, and what is the clustering and what is the virtualization? Virtualization is totally different, isn't it? The virtualization. So this is
Virtualization, like if you remember few minutes back, I'm not sure who asked this open server question. So
okay.
virtualization is related to that. Virtualization is just a solution for hardware. Like if I'm talking about VMware VirtualBox or Microsoft Virtual PC or maybe Citrix or Red Hat or virtualization Zen or something. So all these virtualization are what? VMware is a hardware vendor, nothing else. So what they are doing, they are providing a hardware to your system.
Okay. Okay.
So instead of having physical hardware, I have virtual hardware to run that
Okay.
software. But operating system is original, package is original, only my hardwares get virtualized. So virtualization doesn't have any relation to this standalone or distributed kind of concept, or how many firewalls you are going to manage. That's nowhere related to it. Only the thing is I don't need to purchase hardware.
Okay.
Next, coming to your question that if it is going to manage hundreds of firewall, then what's the difference to the SMS? Was it your question? Hello? Hello?
Sir, I think let's take a break now. We'll be back at 4:10. Let's take a 15 minutes break, guys. And I think once we come back, we can start installation, sir, right?
Yes, yes.
Yeah?
So everyone is okay with this?
Yeah.
Yeah, so guys, let's take a 15 minutes break, please.
15 minutes from now. So, okay, we
For
are going to collect.
4:10. We will be back at 4:10.
Okay, fine, fine.
Thank you.